good. So we talk about 3D sensors, about sensor. So basically, the sensors include the stereo. Actually, most of the sensor, the theory of the 3D sensor are from stereo. And so we'll focus on stereo. I will mention a little bit about time of flight and mention about structural light. This is the application of stereo. So why we need 3D? Why do we need a 3D? For example, if you take only one image, and you'll find from the foreground, there's two objects, there's two persons. If you only use one single camera, and you'll find the frontal one will occlude big one. Actually, it's me. 这是我啦，在我公司的时候，那是然后是一个俄国人，俄国的数学，共产党他们数学，他们教的数学跟我们不一样。数学教那个整个组织什么跟我们不一样，他有拿给我看过他们的书，可他们很强，他们那个制度的数学上很强。然后俄国人是这样子，我下面因为我那时候当主管嘛，去公司那边，后面公司从21个人变200人，变600人嘛，我当主，后面就升了，因为我算早点进去。然后在伊朗对不起，在伊朗还有个强度是那个印度人，伊朗是俄国人。他如果在华氏80度，他整个脸是红色。华氏80度，我忘记摄氏几度。华氏80度的时候，他整个脸是变红，通通的，然后又不舒服，他会很不舒服，他就开始要跟我们公司在华尔街那边，所以那个世贸中心91撞到那个我看到，刚上班啊，然后我是主管，所以我有窗户看到我这样子。我是撞到那个我没看到，但是我看到是第一辆已经撞了，然后去坐地铁去的时候，第二又撞上去，倒下来我有看到，吓到了，也有空再讲。然后回到这边，然后他在华氏80度就不舒服，就常常跟我请假，那真的整个身体皮肤都变红色这样子。可是反过来讲，他越冷就越兴奋。然后我记得那时候大概因为华氏32度是摄氏0度，就这样。然后在30几度的时候，因为他住在那个布鲁克林那一边，那边是大西洋，然后会跟我讲说，他说那时候我早上6点多爬起来，然后裸奔到大西洋去，早上没人，因为冬天没人，头光光跑去大西洋游，很高兴，因为他住在那一边，然后再来上班，所以他冬天他整个人都很兴奋，精神都很好，这样子，穿着短袖这样子。另外一个那个印度人，强度印度人，他刚好相反，他大概华氏，因为美国是华氏大概40-50度的时候，40-50度，他就穿那个大的那个雪衣，穿的受不了，就流鼻水这样子。可是他越热就越兴奋，好兴奋。他是温度越热，他就整个精神就很好这样子。那只是说常吃那个咖喱哦，所以才会咖喱那个。我最后才知道为什么印度人喜欢用古龙水，因为他们不洗澡。看到很多印度人，有些人高高帅帅的，他都喷那个古龙水，很香，对，就是他们就色色的这样子，回去找女生这样子，你看喷那些古龙水很香，但是重点是不洗澡。你强度跟我说，我这个民族不喜欢洗澡，因为没有那个泥，恒河嘛，是 跑进恒河里面，那恒河里面有尸体啊，什么都放在恒河，他们是从出生到死都是恒河脏脏的这样子的习惯这样子。然后另外印度人是这样，我刚开始跟他们就是要管他们，要指导他们。那我跟他讲话的时候，他不管是对或不，他讲 yes or no，他头都这样子。你去看那个印度那个电影，他们头是这样 yes or no，no 是这样子。他们头是这样，他们很爱跳舞，这样。我说刚开始气死，到底 yes or no，你到底懂不懂？懂不懂我讲的话？然后他有时候因为他比较年轻，会害怕，就这样懂，搞不清楚。最后才发现，这是 no，他们印度人这是 no，就头这样子，这是 no，这样子。他头不动是 yes，他跟你讲 yes，他头在动就不好意思拒绝你，但是是 no 这样子。所以他们 no 是这样子。我知道因为最后很熟，大家都感情都很好。所以他这是不同文化还蛮好玩的，就手的，还有遇到那个叫什么拜阿拉的对啊，到那个斋祭的时候，一天好像要5次嘛，就看他从那个抽屉里面，我们置物柜里面就拿一个毯子，就涂在那边，就在那边那个，就他们宗教关系这样，很虔诚啊，都很虔诚。然后他们在跟阿拉敬拜的时候都不敢讲，他们民族也不一定每个人，可是我遇到那个都蛮壮蛮高的。对，那我们那时候911后很怕，对，有那个上面有卷那个是那种，所以我们在搭地铁的时候看到那个就不敢，那班车不敢搭，这样子。OK，但是不应当这样，但是真的那时候。来回到这一边。Okay, so for one single camera, you cannot segment, we get segmentation, 区分 segment the front and behind. But if you have depth in information, the depth or disparity, I'll talk about disparity later. The depth information you can segment the frontal object and the background object. Okay, so this is Idan is me. 同时走道还蛮长。好，这是那个 stereo. So why we need the 3D camera because it's easy for segmentation based on the depth. So 3D camera not limited, but before this year or 2 years ago, you have we call stereo. It's 2 camera. This one is about 20 years ago. They have this one. I forget its name. Great Point. They released this one. This cost 100,000 NT dollars. This one only 2 camera. 这10万台币哦，这一组要10万台币。这个现在不用了，现在很便宜。And the other kind of flight is meaning the flight is meaning like ultrasound, 超音波. So they have inject some wave, and then based on the time it flight. Okay. So the connect two use the time of flight. So it's based on this some transmission from this one and flight. And if you close the object, the flight time will be shorter. So that's meaning the object close to you. So it's like a laser or the ultrasound. 像超音波这样打出去嘛，再回来这样子。And if the object is further from you, then it will take a long time. So this is time of flight. And the third one is we call structural light. 打那个叫结构光 structural light. And this is projector. This kind of projector is the same projector. Okay. So usually three kind of we get 3D things. Okay. If I do the comparison of the 3D things, actually this table is already a little bit old. It's when my lab work with the TI. 那时候我跟德州仪器合作的时候，他们有做这些东西的，大概十几年前的。我是他的 part， 实验室是他的 partner， 所以那时候是跟我讲这是他的机密了，现在已经不是机密了。那我大概讲一下 stereo。OK，so for the 这个表示我那时候有帮他们做错了，给我看，我说这做错了，帮他改。当顾问，所以你不要以为那大公司不会做错，大公司做错，这个做错是这样子，帮他改过。So for the software complexities, meaning the software itself is more, you need more source code to write the code to solve the problems. So you'll find structural light is complicated. Time of flight is easy because it has an ultrasound laser, so it's easy. And stereo is between, just middle between them. But for the cost, 价钱 the structure is very expensive. It's about more than $100,000, 10万块以上。Time of flight is cheap. It's about $4,000, 是4000块左右。Stereo, because you need to stereo into 2 cameras, so a little bit expensive. So this is cheap. So that's why Connect 2 use this one. Connect 2 is cheap, but no more Connect 2. And response time. Okay. Basically, structure that has high accuracy. The accuracy for the depth can be less than 10 micrometer, 10 millimeter 以下。1 million is 10 的负6次方。So this high accuracy but slow and expensive. This is easy way. Anything is high accuracy should be expensive. Okay, but slow. And for the time of flight, see this is cheap. It's cheap, best, but for the accuracy is like 1 millimeter. So you find Connect 2, the depth information, the depth accuracy is 1 millimeter. And right now, the Intel RealSense, the depth resolution is also 1 millimeter. 你会发现不管怎么做，目前包括 Connect 2、RealSense、Intel RealSense， 它深度的解析都有1 millimeter。为什么？你现在技术就知道这样，还没有突破，所以这是 1 millimeter。And for the stereo, the price is just okay. But the depth, the resolution is also not good. So stereo, the depth resolution is the worst one. Now stereo 的精度是最差的，一般来讲精度最差的。那为什么这3个 ？Why we need these 3? So basically, I explain to you. If you have a long distance, like you have the car, right, or the automatic car, or the Tesla, the car. For the long distance here, should be like here. Okay, so more than 5 millimeter or even 100 millimeter, you can use stereo. So some satellites in the United States, they have a stereo there, so they can see the height of the building. 美国呢，我看过，因为我在美国是跟军方合作的，所以很多武器我都看过。那时候我拍一个计划，不是我们公司做的， 我们公司做了脸辨识，还有 stereo， 我那时候是我拿了500万美元，DARPA 的，就是做 stereo system。real time， 那时候电脑很慢哦，我们做 real time， 而且可以从那个公司在纽泽西去控制在那个 Minneapolis 控制那边的东西，这样子 stereo， 因为他用镭射要去杀那个 stereo 定位完镭射要去把敌人的头传掉这样子。那另外一家公司好像是现在很有什么一家公司，它做什么？它可以从隔壁去侦测这个有几个心跳，几个心脏在跳，隔壁，然后用那个磁波，然后去从这个墙壁这边去量说这里有几个心脏在跳，就是说这里有几个敌人的意思，它可以定位定期，定位定好。所以那个时候我在做的时候，我跟搭档的时候是1998工作到2002，然后会成大事情这样子，跟搭档，然后跟那些军人在吃饭，我也当过，那时候当兵嘛，他们军人吃饭都是带枪的，在部队里面，所以他们都带着枪跟我们在吃饭。他们军人是有福利啊，吃的很好，美国人吃东西要吃的随便你拿，然后大什么大，要随便他们在军人福利，比如手枪这样，在部队里不是就像军官就配着枪威武啊，对我们很好啊。他说你从哪里来？我说台湾来吧，We are friends，台湾是他的 friend。我就问他，Who is your enemy? China 所以很早他就把大陆定位成敌人。但我们的国军从以前呢，从2次大战就跟他们有教，他们有上课，从2次大战，反正美国军人比较知道台湾，美国人一般人不知道台湾，他们以为台湾跟台湾是一样的，台湾 equal to 台湾，因为台湾比较大，台湾很小，美国人地理是很差的。像我老板日本人他也不知道台湾，你不要以为日本人都知道台湾，我老板不知道台湾，因为我是他唯一一个台湾学生，对台湾不大了解，是小国家，一般民众都搞不清楚，没听过台湾那么小，他知道亚洲，他知道亚洲只有日本，他们有时候有时候听到说哦台湾，Oh it's good area，然后他说 Can you speak Japanese? Japan 就你会讲日本话吗？说我们不是日本人，因为他们印象中印象中亚洲比较高级的人是日本人，他比较那个是 Made in China 的这样子，他们就这样，其他国家都不是很在乎这样子。啊，知道越南，因为越南打过仗的，所以就大概外面实际状况是我所遇到的，他们除了对美国那些比4个球类运动有兴趣，他们对其他东西都没兴趣。所以他们的球类比较都世界杯嘛，什么都世界杯，他们觉得就这样子。他们真的是很强。我们再继续讲。So for the stereo, it's good for actually it's good for our low light. Is mean in the situation if it's the low light. That's meaning the lighting situation is not good. So stereo is okay. Stereo is okay for the low light. So it's good for the car. So ADAS is this one. ADAS, the automatic driver 辅助系统 assistant system, automatic driving or driving something assistant system. So for the stereo, it's good for this. And radar has LiDAR, include the LiDAR. Okay, so Tesla, they say they don't want to use LiDAR. They just want to use vision. Why? Actually, LiDAR is good. To me, I prefer combine LiDAR and the vision. But why Tesla they announce they don't want to use LiDAR? Instead of they want to use the vision. Now, one camera they have probably they have more than 10 camera for the car， 可能10几支摄影机。那为什么？Well, actually, before I just confused. So I use Messenger, talk to my friend in United States, American, because they are the Google, some friend of Google. I don't have a friend working in Tesla. I have a friend working. This is because they have a friend in Tesla. My friends in Google and Microsoft, they are senior, they are manager, so they have more information. They ask their friend. It's because sometimes the information will conflict between data and the region. 会有冲突。data 就是 so sometimes because data can detect the object in a longer distance, and region is closer. But for the reliability, 可信度, region is better than data because region you can see the image. Data just point. So for the long distance, it's fine. Long distance data can detect the object. But the Tesla people feel okay, long distance I can still use the long focal length camera, so I still can see the far away object. 你要看远距离，就把那个摄影机焦距换长大一点，就看到远距离。他说 ，so the most important one is the confliction between data and the camera， 两个会起冲突，就是意思是说 ，sometimes data detect this is a dangerous object, so they have alarm, but for the camera they feel this is okay, it's not dangerous, you don't need to have a brake for that one， 你不用踩刹车。那你要相信谁？ The finally they feel okay. Finally, the reliability, reliable camera is better than data 这样子。最后他发现测完，他发现哎，还是摄影机比，因为摄影机看到啊比较准啊 ，data 只有点而已啊，点有时候不准。那车子那个有一个要注意一下，很多人开特斯拉是要死掉哦，不是很多人，不能讲很多人，有人呢。那大家都不知道，因为他不会讲。但是有人在特斯拉自驾车，你看到哇，很多人自驾车在路上然后睡着了，被拍下来，好像很厉害。是他没有发布消息，特斯拉撞下去的那些 case 没有讲。可上内部得到消息是不少就是撞死，就太相信他被撞死。也曾经，伯克莱一个老师来讲，他也说过，他说那个我们的一般高速公路，我们这个台湾还好，高速公路出口是在右边出去嘛，美国是高速公路出口是在内车道这样上去。他说有个 case 是内车道嘛，然后出去，然后那个有个三角形这样，就有个很奇怪的，然后特斯拉从来没看过这个东西，就从内车道爬上去再降速，1.1公里知道，他搞不清楚这是什么东西，然后他就变成那个就是车道就是变成本来是一个车道这样子，那个车道上去，然后他把它变成中间又是第三个车道，就加速中间加速上去，然后就撞到那个中间那后面就打车死，就他以为是车道变成2车道变成3车道，实际上是2车道，他误以为中间那个分割又是因为又慢慢分越来越快，还可以，你看真的到以为是第三个车，就中间车道加速，然后那个人也是就睡着，撞进就拜拜这样子，那个车祸听说很惨，就是整个车都因为加速上去，他有拍那个他有给我看那个照片，所以，坐自驾车的人不敢开自驾车这样子。那他啦，不是我的，那是伯克莱一个教授，他说他不敢开，但是他在做自驾车。OK， 好， 仅供参考。那再来哈 ，OK，so stereo is good for the longer distance. So ADAS is good. For the time of flight, what kind of situation is time of flight? Is the distance between 1 to 5. So for the human robot or human computer interaction, it's good to use time of flight. This one. 近距离的摄用 time of flight. Because the price is low. Price low, it's fast. And the depth information 1 millimeter, it's good. Because if you just have small motion, they still can detect your motion. Or gesture, use gesture. So time of flight is good for this one. Gain control of human computer or human robot interaction. So this is good for this one. Then finally is structural light. Structural light is for the measurement, for the high accuracy of structural light. So when you develop structural light for this one, for the inspection, you can use structural light. So longer distance stereo. The human computer interaction is a time of flight. The structural light here is this one. Okay. 然后那时候，光宝有个副总，到旁边打听到我，他说要来跟我讨论他们公司要发展，那时候7、8年前我就梦见，是要发展这个，他不知道总那个，他就来跑来跟我谈，然后我就给他看这个3课，那时候就有3课讲，跟他分析这些东西，因为他市场要团队，他分析大概谈半个小时，一开始有一些要谈半个小时，然后半个小时他就说李老师，那谢谢你让我知道这些资讯，那公司顾问费就是1万块，对，就拿1万块给我，都不能收，不早点讲。是不能收，不行，要收，公司规定要收这样子。然后我说不请我们实验室的学生，他说但是要有人签名，但我就签了啦，就半个小时的顾问费讲这个，最后就聊天聊他们后面因为光宝好像那时候在决定。有些公司他决定，他要做很多摄影机的那个，那时候跟我讲说，摄影机的类似，他们做很多那个很 cheap 的类似。好，所以当顾问就是说讲这些东西。所以你看到很多表格给你们，那是我有时候是当顾问去整理出来的。好，再继续往这边讲。So this is basically 3 kind of sensors in this table. 我的讲义很乱，因为我不管是叫学生帮我做，我都自己做。有些是学生做完把它拿过来，但是我们内部讲义所以很乱，我没有时间再整理这么就做整理的像那个李宏毅老师那么漂亮。李宏毅老师不简单，他做的很好，也动态什么做的，所以他上课的东西你们可以去看他的东西。我听过几个真的讲的非常好。那我没有时间去做这些东西，我就直接把我们内部的讲义直接拿出来给大家。OK， 我 continue. So the other one, you don't have this one. Just last night I include this one for you. So right now I have the Intel RealSense. After I show you the Connect. That's why I show you the Connect video 3D. This is show you something. This Connect one.
Microsoft's Kinect has a depth sensor that can tell how far away things are. In this stream, brighter colors are closer and darker ones are farther away. This video will explain how the people initially
This Connect one.
figure out the perspective of a camera. This is where our second eyeball usually comes. If we draw lines from a rabbit,
I want to show you the structure light.
so
This is connected one.
Connect.
See the dot. You can do real time.
Discovered
So before I talk about structural light, and structural light I say is high accuracy, but it's slow. But this is the other kind of structural light. It's easy structural light. It projects a circle point. A circle point. So connected one, right now we don't use connected one, but connected one, they have a laser. They will hurt your eyes. So connected one will hurt your eyes because they project some dots. 那个点去，然后 because such a
analysis of 3D deformation of human body is
Studies.
essential in biomechanics.
So if you project a circle, right, in the frontal circle, in the right hand side become the ellipse， 圆形会变椭圆形的呢，这边变椭圆形，这边变上面会变成椭圆形，右边会变成椭圆形，所以它用打圆的点，然后 if the close to you, the circle will be bigger. Far away from you, the circle will be smaller. So based on the structural light, use a circle, they can measure your depth information. That's connected one. But connected two, they don't use this kind of structural light. They use kind of light. So they have an infrared. 他们有个 near infrared， 它远红外线去打。So connect two is kind of light. Okay. So if you go to the internet, you can find some information about connect one, connect two. And for the real sense here, this Intel after connect, they start to produce the connect one and connect two. They focus on HoloLens. Okay, Microsoft they focus on for HoloLens after connect. Okay, but HoloLens is, as I know, is for the virtual reality, but very expensive. So at this time, Intel they produce the real sense. So have these tests 415. Okay, so this is the real sense, and this very cheap. It's about like 6K. But anything is doing good. So this is for the again, this is for human-computer interaction for closer distance. So this is real sense. And this is the other one. It's a 435. One is a 415, the other 435. So if we see the accuracy is 1 millimeter, the minimum accuracy. Okay. 它是1 mm 的距离这样子啊。然后 can do it longer distance actually it's about 8 millimeter. So here we see this one. So they have one black and white two camera. So they're stereo. They use stereo. But they have one projector. This kind of projector. Okay, and use stereo. But this both are black and white camera, and this color camera. This color camera. So you feel the distance a little bit shift. 它距离会有点 shift 的，因为这是 stereo 的 depth information and color information. So if you want to merge the depth information to color information, you need to do some calibration. So 校正 for high accuracy. This is the accuracy. So longer distance for stereo. Stereo has this kind of problems. If the distance is longer, this is a 50 centimeter. This is millimeter. So this is 1 meter, 2 meter, up to 4 meter. After 4 meter, the accuracy is getting worse. 精确度会变不好，精确度从20 millimeter 开始变不好。这提供你参考一下。So after death, by sorry, 415 and 435, and then right now is this is LiDAR 515. But my experience, the experience from our lab, this is not so. Compared with the previous one, this more expensive. It's about $12,000 1/2左右, but the result is not better than previous one. 这结果没有比较好。那 this is for the see this one. This is laser LiDAR. Originally, I assumed LiDAR would be better. Not so. The result is not so good. It's okay, but compared with previous stereo, this is not stable. So this is a lens, sorry, a mirror. So this is project here, and this will be a mirror. 这是块镜子，那镜子会动，会这样去上下动，所以这是 for 3D. Only one laser beam, but this one will move, not only turning 360 degree, but also there is some tilt. 它会上下动，所以会这样扫描，一直扫描下来。在这边会，这里会这样扫描。你物体在这边嘛，会扫到，这样扫3D. Okay. But this real sense probably they will stop product. But I don't know why, because they sell this one very popular, but they don't want to do it again. I don't know what's the reason. And right now, new one is LiDAR. 2D LiDAR is cheap, about $20,000. 大概2万块，或者2万多块是 2D LiDAR, only for 2D. But 3D LiDAR will be $100,000, 10万块以上。那个 3D LiDAR 比较贵。这 for your reference. Okay, so we will talk about the stereo later. The stereo, and then I'll talk about this one in detail. And this is for the time of flight. Okay, and this is very similar to the Canon 2. So they have a infrared camera. This is RGB. There is some, sorry, this is laser here. But actually, they have an infrared camera inside. So this is like this time of flight. So time of flight like this one. We have a chip and this camera. And the important one is that we have a point cloud. This is called point cloud. POINT CLOUD 电云图 point cloud. So all the 3D sensor, they will produce the point cloud. So based on point cloud and combined with the RGB camera, and we can do the gesture recognition and do detection, tracking, recognition, human-computer interaction. So based on the point 3D information, we can do this kind of process. 后面就你自己看就好了。这我们以前跟德州仪器合作的，就提供以上，这已经挺惨的。There's some results. See, this is one finger become 2 fingers because we did not do well about alignment. Alignment doesn't do well. But this is we do for the TI. TI try to beat and connect. So they have this one. They call soft kinetic. So the other one is I don't teach structural light, but we teach structural light. What's a structural light? This is for high accuracy. See, this is for slow motion. 就不要随便打人，打下去是很可怕。打下去没有，但动作。 slow motion.
and biomechanics. Collision analysis commonly carried out in car industries to assess
So what's the structure like this one?
component analysis.
This is a camera. The DLP is a projector. They will project some structure because this is no texture. So for 3D reconstruction, if we have a more texture, we can do the 3D reconstruction well because we do need to try to find corresponding point. If there's no texture here, it's not easy for 3D reconstruction. So we use the projector, but project some texture in there.
Let's see the inside of the projector.
So the projector. And this is inside the projector.
Each mirror on DMT can switch pin.
So this is structure light. 它会打条码
Only a single
because you don't have a
image is
texture, so
projected
we just some
by the
structure.
projector.
结构光嘛，它打条嘛，这样就 so you have a more texture
The illuminated scene looks
because
static.
because you don't have a texture before.
But when we capture the scene at 3000 Hz,
So based on the texture,
now we show the
we can
estimated
reconstruct
corresponding
3D.
stripes. The text map shape of a static structure is rendered from multiple viewpoints. Example shows the 3D.
And also they can do the
motion.
motion, 3D reconstruction from the
That
motion.
the object is blurred in 60 Hz video. High-speed video at 3000 Hz gets 3D deformations of the hand. The slow motion video of the deformation can be easily generated because we have 3000 depth frames per second. Now, successive
So let's structure
depth
that.
is required at 3000 Hz.
So they have a more, the object is more,
Deformation of
more
the shape
texture
is
inside.
rendered at real-time speed and
It's
face
the same.
expression.
But because this is strong light, 那个强光哦，那不能看，眼睛会伤害，所以它眼睛要闭起来。这个
We can generate 3000 depth maps per second by sliding the window with 25 frames along time.
so
Now
you
show
can
the
close
result
your
of
eyes
face expression.
and do the structure light. So they can have a high accuracy. So structure light is for high accuracy.
We have presented
So back to here. So structure light is here. Camera, one projector, and they can reconstruct any object in high accuracy. That's called structure light. Just give you an idea. Structure light can apply because of high accuracy. So we can apply on this count. You see, it's structure light here. So they can reconstruct the big object. 打那个结构光打上去。So for the automation or industry 4.0，就是工业4.0啊，就用到这边自动化，因为这个都没有 texture，所以要打那个结构光打上去，然后再把拼图拼起来。这只要200万，那时候卖的时候就200万。知道一下这结构。Structure right here. So they come, many robots will use structure light in industry. 那是协奏型的两个 structure right here. 这是他打出来的侦测，去把这个化妆品组合起来。这是那个摄影机看到的，对，这一组看到有组中。So you can see more robot will be operating with you, operating with you, and they have eyes here, structure like here, more stereo here. 这个 you pick select the target. And my lab also do something like this. 我实验室在做这个，一堆东西的。So you'll find the more application this kind of process. 可是这种无聊工作就要让他去做，看的人都会觉得无聊。这样structure line. So what's the purpose for this one? This is shoes. So I think in the near future, probably when you try to buy the shoes, you don't go to shoe stores. You will go to Starbucks. So you go to Starbucks, and they have a scanner. This one, this scanner, and you just let them scan your feet. 然后扫描你的一个鞋，你的那脚。And you can use the internet based on the size, choose the shoes model, and probably next week they will deliver your shoes for you. The important one is your left foot and right foot, the shoe size will not be the same. 人的左右脚是不会一样的，所以到时候你的鞋子是会定做的，你的左脚跟右脚的 size 不一样。So next, I think in the future, you order the shoes, just go to Starbucks, and they have a scanner there. You order a cup of coffee, and you see your foot under the scan, the software light scan because it's a millimeter accuracy, and you choose the color of the shoes, right? And then order it, and next week the shoes will deliver to your home. 可是它是会改变后面的整个世界这样子。Okay, so this so we next hour we'll talk about the deep learning. So we take a break.